Hello and welcome to Mellow Labs. On today's episode, I'm solving a problem. It's this shower curtain. I have to manually move it left and right whenever I'm going in and out of my shower. I'd really rather this be an automated thing. So, on today's episode, I'm making my shower curtain smart, right after this message from my sponsor.
JLCPCB. With 19 years of experience and 5 state-of-the-art factories, it's no wonder that over 5.4 million engineers across 180 plus countries rely on their reliable and affordable services. Getting started is easy. Simply upload your Gerber files, get an instant quote, and place your order within minutes. It's just that easy. Whether you're prototyping or producing in volume, JLCPCB offers unbeatable pricing with 1 to 8 layer PCBs starting from just $2. But it's not just affordability. JLCPCB delivers premium quality with lightning turnaround times. Your boards can be ready within as little as 24 hours. All thanks to their fully in-house production process, which ensures quality control at every stage. And right now, there's an exclusive offer where you can get 6-layer PCBs for just $5 with $30 off of your first order. If you're ready to take your electronic projects to the next level, visit JLCPCB. Okay, that's a lot better. So the basic idea for this project is to have a thing that will kind of just like go up and down the rail that holds the curtain in place. Let me just... I'm basically just gonna try to replicate what SwitchBot did with their like curtain thing, but DIY. So I'm thinking I'll have a motor, a wheel, and maybe like 2 other wheels, and I need to like somehow tension these down so that they stay on the actual rail, and then somehow we need a battery and a motor driver and probably like an ESP32 or something, and some kind of way to know how far we are from each end. I just realized that like this is quite a lot of weight, and if I'm tensioning these down, I'm gonna have to like add extra tension to tension this down because this is going to be pulling it down. Okay, so I clearly have a lot of things to figure out. Let me do some more pondering on the computer in some CAD design software and see what I can come up with. Okay, so this whole thing took me a little bit longer than I expected to design, mostly because I got distracted with some Twitch streaming.
We're no strangers to love, you know the rules, and so do I. Before commitments, what I'm thinking of, you wouldn't get this from any other guy. Pre-chorus, I just wanna tell you how I'm feeling, gotta make you understand. Chorus, never gonna give you up, never gonna let you down, never gonna run around and desert you, never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you.
Link in the description, but here's what I have so far. So the battery goes here, the ESP and motor driver will go here, attached with hot glue. We've got a motor that will just screw in here. We've got a wheel and a TPU tire that's on top of the wheel, and then this wheel will have some bearings in it, and again this wheel is printed in TPU, and then we've got like the shaft that will hold that wheel in place, and hopefully with a single rubber band I'll have enough force pushing this wheel down and pulling this up to like actually stay on track and, you know, not have enough traction to actually pull the curtain back and forth. Hopefully that works. I don't know yet. So that's the plan. I'm gonna go print it out and then we can test it out. After a few hours of 3D printing, we have hopefully all the parts we need to assemble this. So the motor should go in here with some M3 screws. Let's pop those in. That's all 4 screws screwed in there. So now we've got one TPU wheel, which this one has a thing that goes inside of it, like so, and then that goes on this motor here, like that, and that should be in the right place to accept the rail. The other TPU wheel has room for some ball bearings, like so, and then the shaft goes through there, and then that goes in there, and that should spin nice and freely. Now this bit is a little problematic. So that rubber band goes there and there to hold on to the wheel, and that it does pull it down. I don't know if it has enough force to actually, you know, be good at what it does, but it should work. Now this bit glues on there. My glue is all over the place. I need a new bottle. Anywho, like I said, it's way too much glue. Oh, god damn it. I'm gonna sacrifice a tiny paintbrush. I'm gonna paint that on here. Oh, that's way too much glue. Okay. Well, everybody say RIP to the paintbrush. That is so much glue. Okay, and hopefully, did I make that tall enough so that the motor can actually... Yes, I did. Okay, fantastic. So that goes there. Let's hit that with some activator. Okay, the battery is gonna go there, and I'm going to make sure it stays in place by just adding a rubber band right there. Fantastic, and that's perfect. Right, I want to test this, but not with an ESP or a motor driver just yet. I'm actually going to test it with this, which is a H-bridge switch, which literally just switches the direction in which the motor goes. So if I put these crocodile clips on the input for the motor, right there, and then, ooh, bye-bye, and then I can put these in here, and that's gonna make the motor spin, and we can change the direction by just flicking the switch. And turning it on and off is handled by just removing these two. Okay, so let's go and test that out. My partner just finished showering, so everything is very moist. Okay, let's unclip that. Unclip that. Oh, I'm not going to be able to grab that again. Okay, and that should go on there. Oh, I can't. The rubber band went down on here and I cannot get it out of there. Ugh. Okay, I think I figured it out. So, I've got the rubber band hooked on this little lip here and around here. So now, if I put that there and that there, we can now grab this part of the rubber band and put it on this wheel, and grab this side of the rubber band and put it up on this part of the wheel. Okay, that's pretty good. I thought like the weight of it was gonna be an issue, but it seems to be okay. Cool. So now if I plug it in, oh yes, other way. Yeah. Okay. Okay, that seems to actually work. Okay, shower curtain. Shit, I didn't think of a way of attaching the shower curtain. Maybe if I just rubber band, can you, hold on. If I do that, if I just do that, and now if I connect it back to the battery, oh yeah, okay, and other way. Okay. Seems to be doing its job. Yeah. Okay. That seems to be doing the job. That's not bad. Okay. And let's see if it can. So there's because this is an telescoping shower curtain rod holder thingy, there's a little ridge here. Let's see if I can actually get over it. Okay, with like a tiny push. Okay, other way, please. Okay, with like a tiny push, it seems to be able to. Maybe if I put like tape around here so that it's less of a bump, more of a Actually, maybe it's just because it leans down, the gap on the bottom is bigger than the gap on top. So maybe if I just push that up, maybe that will actually solve the problem. Hold on. Backwards and forwards. Okay, that kind of. Okay, well, the rough idea is there. It seems to work somewhat reliably. I think we can put some smarts in here. And also, I think I need to add like a limit switch on this side so that when it hits the wall, it knows to stop. Okay, I think I have a plan to move forward. So, back to my desk. After rewatching the footage, I realized it gets kind of stuck in two places. So, first of all, it gets stuck on the actual like side here. So like because the metal thing extends below this, it kind of gets stuck in here. That's kind of an easy fix. In the model, I'll just like you know, add a nice feature to like make it smooth so that the pipe just goes in there nice and smooth. And the other thing is, I think the wheels are actually too smooth. Like, I don't think it actually has any like grip to try to grab the lip of that pipe to get up on it. So here's what I've done. I went back into Fusion and oh god, it's so slow. Is this because I have Premiere open? Yes it is. Okay, fantastic. So first of all, if I just add a lip here, like so that the pipe doesn't have any like obstructions, it can just slide in. And for the wheels, I actually just added some you know, ribs for the pipe's pleasure, and hopefully that's enough to like actually like jump onto the pipe. I've already printed them. Sadly, the first pair I've designed, the ridges were definitely way too small. Like, this is still pretty smooth. So I went back and I reprinted them again, and now hopefully that's enough you know, bite for it to actually grab onto. So I'm gonna just actually, yeah, since I'm already here, let's put them on. The screwdriver in, take the little wheel out, force out the little inside bit, and then force it onto this bit. Oh no, it doesn't fit. Oh yes, it does. There we go. Okay, nice and snug, and we can put that back on the shaft. Perfect. And now the other bit with my 2 ball bearings. Okay, we can do that, and that should go in here like that. Now I should really reprint this so that I can have that lip, but I don't really want to, because like this is quite a lot of plastic. It's going to take quite a while to print. So instead, I'm just going to just file that down. So hopefully the pipe can actually go in there easier and saves me reprinting this again. Okay, let's go and try that out. Okay, let's give this another go. That goes on here. That goes on here. And now that goes on there, and this one, oh, I can't grab it. This one goes on, this side is definitely tighter than the other side. Let's see if I can balance out the stretch on that band. Okay, that seems good. Okay, let's plug it in, and let's see if it helps. Other way, please. Oh, come on. Down. Nah. Okay, it seems to be getting over it. I don't know why it didn't want to in the beginning, but now it seems to be like doing it. That's weird. Yeah, no, I'm not putting any like force on it. It seems to be going down it fine, and come on. It really wants to. It's like if the top wheel was powered, it would have zero problem, but I'm not making the top one powered. It seems to mostly work. It's just like The bottom wheel's pulling it up, but it doesn't want to go up. That's so annoying. Let's attach the curtain and actually see it pull it all the way through. Okay, well, it does it. I think I am going to try putting some tape on here and see if that helps it at all. Okay, so hopefully that is a good enough ramp for it to work perfectly each time. Let's try it. Oh yeah. Back. Oh, perfect. No struggle. Beautiful. Oh, I just realized I completely sanded on the wrong side. I was meant to sand this side so that this is the bit where the lip hits, but I sanded down this side. Well, that's stupid of me. Well, luckily, it doesn't seem to have made a difference because it works perfectly fine. So, I need to figure out a couple more things. But we're getting there. We're almost there. So the next thing to tackle is for it to figure out when it's gotten to the end of the curtain rod. So we need a sensor on this side, which I think just needs to be flush with this side because that's where it hits the wall. And then we need something on this side so that it, it bunches up the entire curtain and then knows to stop. I could use something like a distance sensor to figure out how far away from the wall I am and stuff like that. But I think what I actually want is just some end stop switches from my old 3D printer. Just put them at the ends so that when it hits the wall, it triggers the switch and it knows to stop. So I'm going to design something to go in here. I need to figure out how far we need to go out to this side, because this side I can pretty much just make it flush with that and that will work. So let me do some CADing. To add to the silliness, this is what it looks like now. We've got two end stop switches, one here, and they're at the end of these, what would you call them, wings? Arms, whatever. So this one needs to be 160 millimeters from this middle bit, so that it actually, bunches up the entire curtain here and then touches the wall. So that's the correct length, and that, like I said, it just needs to be as long as the battery sticks out here. So that's pretty much just flush with that. So I'm going to print these, attach these end stop switches, and then we can see if we actually get proper connection on those when it hits the wall and stuff like that. So let's print those. 45 minutes later, these are printed and they look pretty good. Like I said, they're just kind of long sticks with switches at the end, and I've got the switches attached with some M3 hardware and some spacers because the solder joints on here are sticking out, so it didn't mount flushly. So I just have some spacers on here to keep it away from the thing. So that it now needs to attach to here. Now, once again, I am not a smart person, and this is more of a prototype than an actual finished design. So I am going to super glue these on here. Let's hope the super gluing goes better than the last time. Ah, damn it! No, it did not go easier than last time. Okay, well, shit. Maybe I can, hold on, if I put that way, that way, this way, okay. So if I get the super glue from there and put it on here, and I did not think about this. Han, could you do me a massive favor?
Okay.
Could you grab the activator spray and just
Spray you?
just spray this bit? Yes, please. Ah, you got my finger. It's fine.
It's fine.
Thank you. Oh, this one's bent. It should work. Let me go and test it out in the bathroom. Okay, so this one should be long enough to hit that bit there. So if I put that on here, the wheel still slides on and off perfectly fine. And when I push that all the way to the end, apart from breaking the wall a little bit, that hits perfectly. So that is actually going to work. Very nice. And the other side, that should go on there. And if I push it to the end, It does it. It hits the switch. That is perfect. Okay, cool. So that's gonna work exactly as intended if I can get all the electronics to work properly. So with that said, let's go and do the electronics. It's the next day. Yes, I'm still wearing the same shirt. Deal with it. Anywho, look, I got this working. So, I've got the motor driver, I've got the ESP32, I've got my two little limit switches, and I'm using a controller. This is the one that I made for my little droid bot. It's got a little joystick on it, and it just uses ESP now to communicate. So, I've got left, right, and I've got these configured so that if I hold this one down, it can no longer go that way. And if I press this one, it can no longer go that way. So, and I've also have buttons on here that will make it go one way all the way until you press the button. And then I've got another button that will make it go that way until I press that button. So that works pretty well. So let's go test it out in the bathroom. Alright, so I've got it all hooked up and ready to go. So first I want to make sure it like goes over this bit as well as it did before. A little bit of a struggle, but it does get over it, so I'm not gonna complain too much about it. Right, now when I hit this button, it should go all the way towards that wall and stop. Fantastic. And if I hit that button, it should go all the way down there. A little bit of struggle on that, but that's fine. And it does pull the entire curtain. Okay, yeah, no, that works pretty well. The only kind of issue I have, apart from, you know, the whole, like, exposed LiPo battery and everything, is kind of like the way I attach the curtain. It kind of just bunches up funny, but with a little bit more refinement, I think this could, you know, be somewhat better. I mean, I definitely don't recommend you make it, and I will not be sharing the STLs or the schematics or any of the code. So, yeah. I mean, as a proof of concept, it does the job. So, with that, thank you very much for watching. Don't forget to like and subscribe. I'm gonna take a shower, and I'll see you on next week's live stream. Goodbye. Yeah, I am questioning my life choices right now.